Coil coating is an automated process used to produce cost-effective, environmentally friendly, quality products. When coils are fabricated into a product such as metal garage doors, metal building panels, and refrigerators, the pre-painted metal must demonstrate suitable flexibility as the final part of the fabrication process. This video demonstrates how to perform a T-bend test in accordance with ASTM test method D4145, standard test method for coating flexibility of pre-painted sheet. That will determine the flexibility of a pre-painted sheet. Most coil coatings chemically change during the curing process, and this change is commonly referred to as cross-linking. Coil coatings such as epoxies, polyesters, and urethanes change from a liquid coating to a hard flexible film as they cure and cross-link. Too little cross-linking may lead to damage to the pre-painted metal during transit and installation. Too much cross-linking, on the other hand, may create a very hard, inflexible coating. A T-bend test is one method to assess if sufficient flexibility exists. Organic coatings on a pre-painted sheet are subjected to stresses when fabricated into products by roll forming, break bending, or other deformation processes. These stresses can exceed the flexibility or adhesive strength of the coating, resulting in fracture of the coating, which exposes the substrate, or in the loss of adhesion of the coating to the substrate. ASTM D4145 covers a procedure for a simple and quick determination of the flexibility of an organic coating. The test offers insight into the coating's ability to withstand downstream fabrication techniques, such as roll forming and bending break forming. Each of these fabrication methods, as well as the T-bend test, are examples of a slow deformation fabrication. Rapid deformation testing, which predicts performance in fabrication techniques such as stamping and punching, is not covered in this video. Roll forming and bending break fabrication involve the same mechanics and produce the same stresses to the pre-painted metal. Let's first look at what happens when metal is fabricated. In a sheet metal bending process, whether roll forming or using a bending break, the material along the outer bend radius will be stretched, while the metal along the inner bend radius is going to undergo compression. Think of coil-coated metallic-coated steel and aluminum from a side view as being composed of a large number of very thin layers of metal. The layer where the compression ends and stretching begins is called the neutral axis, or the neutral layer. The length of the neutral layer does not change during the bending operation, whereas the outer layer gets longer and stretches, and the inner layer gets shorter and compresses. We are most interested in the outer layer and the stresses involved in the stretching process, the cracking that may occur, and the possible loss of adhesion. When testing the flexibility of pre-painted metal, a T-bend test is routinely done. The key to understanding what is happening to the coated metal is knowing the inner radii of the bend. In a roll-forming operation, each bend has been designed with a known inner radii. The figure below shows typical T-bends using NCCA nomenclature, where T is the thickness of the metal. The inner and outer bend radii are shown in the table below. It is important to know the amount of stretching that takes place at the outer layer of metal being fabricated, as this stretching is what the paint experiences during fabrication. It is a simple matter to perform this calculation, knowing the thickness of the metal T and the inner radius of the bend IR. For example, assume a painted metal thickness of 0.020 inches and an inner bend radius of 0.030 inches. The percent elongation would be calculated as shown here. Since it is a T-bend test that will be performed in a paint laboratory or a coil line, and assuming that you know the inner radius of the roll-formed bend that your customer is performing, use this equation. For example, if the inner radius of the bend is 0.030 inches and the metal thickness is 0.020 inches, the T-bend equivalent value would be the following. These formulae also indicate the importance of understanding the role that metal thickness has on the amount of stretching that occurs on the outer area of a bend. For example, consider two metal thicknesses, each of which is bent to an inner radius of 0.050 inches. When working with 0.030 inches pre-painted metal, for example, the elongation is 36%. If 0.056 inch metal were used in place of 0.030 inch material, the percent elongation of the coating is 46%. Thicker metal will undergo more stretching than thinner metal at the same inner radius. Now that you've learned what happens when metal is bent, let's discuss the T-bend tests that are used in the pre-painted metal industry. Although there are several techniques to perform a T-bend test, the goal in all cases is to wrap a layer of metal over on itself, as shown here. A zero T-bend is one where the metal is bent over onto itself. Take note that in the illustration of a zero T-bend drawing, it appears that there is a gap. In reality, the bend is compressed in a vise or a press such that no gap exists. To produce a 1 T-bend, the metal is bent over the 0 T-bend. As the illustration shows, there is 1 thickness of metal between the outer wraps. A 2 T-bend has 2 thicknesses of metal, a 3 T-bend has 3 thicknesses, etc. After each bend is made, it is common to assess the performance of the coating at each T-bend for cracking and loss of adhesion. The degree of cracking may be observed visually or with the aid of magnification. The T-bend requirement, and whether cracking or adhesion loss is allowed, must be agreed upon between the supplier and the customer. Loss of adhesion, commonly called pick-off in the industry, is assessed by applying pressure-sensitive tape to the bend and then rapidly pulling the tape from the bend. The tape is then inspected for the degree of pick-off. Most often, a T-bend specification for pick-off states the T-bend where no pick-off is seen. In the coil coating industry, terminology such as 2T NTO is used, which means that a 2T bend will show no signs of tape pull-off. In the building products industry, where the metallic coated steel is expected to provide the necessary corrosion protection, some amount of cracking of the coating is often acceptable. When performing a T-bend test, it is important to understand the bend direction relative to the rolling direction of the metal. In many cases, the bend is made along the rolling direction. In other cases, the bend may be specified transverse to the rolling direction, that is, against the grain. To perform a T-bend test, a sample of suitable size is needed. A 2-inch by 6-inch sample is a convenient size to work with. Once a bend is made and crimped, it is common practice to inspect the bend for signs of cracking of the coating. Cracking may or may not be a significant factor in the long-term performance of the product. Where no cracking is important, it will be specified at a particular T-bend for those applications. There are several tools commonly used to perform the T-bend test. One technique is to use a bench-mounted bending brake. Once the metal is bent, it is imperative to crimp the metal tightly. This may be done in a vise or by using an arbor press. Assess the degree of cracking at each bend and also determine the amount of pick-off at each bend. For example, if the specification is 2T bend, no pick-off, the 0T bend should be assessed. When the 1T bend is performed, the amount of pick-off at that bend radius should also be assessed. When a 2T bend is tested, and assuming that no pick-off has been observed, as specified, it is helpful to understand the degree of pick-off at 0T and 1T. The pick-off adhesion is easily accomplished using pressure-sensitive tape. Another tool often used to create a T-bend is a wedge device, shown here. This method may also require a vise or press to be used to crimp the bend, unless the wedge device is powerful enough to completely crimp the metal. When using a wedge device, the metal is placed onto the die and the wedge is lowered, bending the metal. The bend typically is not crimped tightly at this point, so the bent metal is repositioned in the wedge device, using the wedge to crimp the metal, or the bend is crimped in a vise or press. As already mentioned, note the cracking and pick-off at each bend. One last iteration to the test method is to bend a triangle-shaped sample. This has the advantage of exposing each of the bends, which may be helpful for initial and future inspection, and serve as a permanent record. The advantage of the production of pre-painted metal is that a continuous web of flat metal is cleaned, pre-treated, and painted under highly controlled conditions. Under all circumstances, coils of pre-painted metal are fabricated and must demonstrate suitable flexibility as the final part is fabricated. Metal building panels, garage doors, rain-carrying accessories, refrigerators, HVAC units, and other products all undergo some degree of fabrication, and the T-bend test is a critical test that is routinely performed on a coil coating line to assure that a proper level of cross-linking has been achieved and not exceeded.